Hi, good morning. In this lesson, we're going to learn the very reason why does color appear. In year 9 and in year 10, we learned that this this object, this pen is red, okay, because light, okay, uh, strike on this pen and it reflects red color. Okay. So today we're going to review the secret of why. Why does certain material reflects certain color? So it all goes, well, this is all because of the photoelectric effect in some way, yes. Okay? So we know that light came in as photon. And the energy it carries, okay, is depend on its frequency. Okay? Yep. Energy is Planck's constant times the frequency of the light. Okay? That's the energy of one photon. Okay? Also, since the speed of light is basically the frequency times the wavelength, I can rewrite this equation as this. So if I take this equation here, rewrite it, so the frequency will be speed of light divided by the wavelength. Okay. Then I'm able to substitute frequency back into the first equation. Then I have this. Okay. So just remember, in the exam, if I gave you the wavelength of a light or the frequency of the light, okay, you can find the energy of one photon of that light, like just using these two equations. Now, we also learned from last week that when light rays strikes an object, okay, it loses electron. Okay. Yeah, it loses electron. Okay. However, in order for this to happen, okay, the energy the energy carried by the photon in those light rays has to be greater than the minimum work function, which is the minimum have to be greater than minimum energy, so an electron can be released. Okay? We call that minimum amount of energy to release an electron the work function. Okay? Or we call it the ionization energy. Okay? So for those students who's doing chemistry, okay, you should heard this before. Ionization means losing electrons, or loss of electrons. Okay? So its work function and ionization energy are the same. So basically the energy needed to make an electron escape. Okay? Now, the real question here is, what would happen when those low frequency photons, those contains less energy than the ionization energy of the metal, okay, strikes the material. Well, the answer would be obvious. Number one, the electron would not escape. Okay. But, okay, but there is another fact. Okay. And it's the very reason that um, object appears colorful. It makes color. So um, what's happened is in an atom, okay, we have the nucleus in the middle, okay, which is positive, and we have the negative electrons goes around it in a circle, okay, in a shell. Okay, and the other thing is uh, for this atom, there are many different shells, right? Or we can call them energy levels. Let me draw one more. Okay. So when the electron absorbs energy, what's happening is the electron is going to move out, okay, move up to the next energy level, and up to the next energy level again. Okay. So when we have photons, when we have high energy photons, okay, what's happening is the electron would just go out, okay, and leave the nucleus forever. And the energy for the electron, okay, to jump out, all the energy level of the atom is called the work function, okay, or energy, ionization energy. Okay, that's the minimum energy that an electron needs to escape the nucleus. Okay. So when there's not enough energy applied to the electron, so when there's photon with low frequencies, with low energies strikes on it, um, what the electron would do is the electron would jump up to the next energy level, or it would go up to the to a further energy level. It depends. This really depends on how much energy it is. Okay. Then milliseconds later, okay, it will return to its ground level, to its original state. Okay. So when does the electrons move up to its energy level, it absorbs energy. When it returns, it releases energy. And this energy is released in the form of light, form of radiation. Okay. So, yeah. So this is basically the very reason that objects appears colorful. So when I look at those red paint, okay, so what I can conclude that the electrons in those red paint um, jumps to its higher energy level and returns back almost immediately. As a result, energy is released, and it is released in the form of light with the red color light frequency. Okay, so if we jump to Google, you can type in an ionization level. You'll find graphs like this. Okay? Just remember the ionization energy of every atom or every material are different. That's why some material needs um, appears in different color, and um, some of them they need more energy. Well, the electrons in some material need more energy to be able to escape, because the ionization energy of different material are all different. Now here is an example. Okay, now let's look at this example. Okay. Now here we have the ionization level chart of hydrogen. So on the right hand side, those are in electron volts. Those are the energy levels in electron volts. Here we have different energy levels. The ground state is the original state of the electron. So if there's no energy absorbed by the electron will remain in the ground state. However, if there is energy more than 13.6 electron volts absorbed by the electron will be ionized. It will be escape. It flies away. Okay? Due to Einstein's theory of photoelectric, it just flies away and never come back. Okay? Now, the trick is, however, say if the energy if we have an energy of a photon with an energy level of 10.2 electron volts, okay, struck on the electron will absorb 10.2 electron volts of energy, and it will move up to the second energy level. Then within a millisecond, less than a millisecond, it will release. Then it releases, and during the process of returning to its ground state, energy is released. Okay, energy is released in the form of light. So and the energy it released is 10.2 electron volts. Using your equation E equals to HF, okay, we can, well, H is the Planck's constant, it's the same, so we can basically type it in your calculator. You can find the frequency of the light it's releasing. If it's according to a color, it will appear in that color. The only thing you need to be aware of is in this scenario is for hydrogen atom, electrons in hydrogen atom will only absorb certain energies of photons. Okay, for instance, it will only absorb 10.2 electron volts. Okay, so it jumps from energy level 1 to energy level 2. Or it will absorb 12.1 electron volts, so the electron will be able to jump to energy level from the ground state to energy level 3. Okay? So it only absorbs certain amount of certain discrete number of energies. Okay? So for instance, if I hit the electron with something like 5 electron volts energy, it will absorb it, but it would not be able to jump up to any energy levels. Okay? Or even if I hit it with energy levels such as 11 electron volts, okay? The electron will absorb it, okay? but okay? but it will not be able to jump to any energy levels, okay? Because 11 electron volts is not exact 10.2 or 12.1. It needs to be exactly 10.2 or 12.1 or 12.7 or 13.6 electron volts. Okay? So, so it only absorbs the gaps between there. Also, for instance, if the electron is already here, actually, okay, if you hit it with the difference between these two electrons, okay, it will not absorb it, okay, because the electrons which are those are already in a higher energy level will not go higher. So that's basically the absorption way of electrons. Okay? So let me show you another Google chart which helps you to understand. Okay, now just remember we call this ionization and energy level chart. Okay? But however, if you go to Google, okay, and search for absorption spectrums, something like this comes up. Okay, so this is let's use the absorption spectrum. Get a little bit confused, okay? But it's the same principle. I gave you this. I try to find. Let me find. Let me find this. Okay, you see this is absorption electron, spectrum for certain material. Okay? So we have increasing wavelengths in this way, so decreasing frequencies here. So the idea is you see those black bands there. Okay? It tells me that that material absorbs this color of light, this color of light, and this color of light, and this color of light, and this color of light only. Okay? It will not absorb the rest of the colors. The electron will not be excited by the rest frequency of light. Okay? So it is basically the same thing as the chart we use here. Okay, now let's do some questions. Question 1, it says, what would happen if this gas was radiated with photons with 14 electron volts of energy. If it's radiated with this much electron volt, 14 electron volt of energy, we can say it is higher than the energy ionization energy. So what's happening is electron will escape due to photoelectric effect. Now, question B. What would happen if the hydrogen was irradiated with a beam of photons with 11 electron volts? Okay. So 11 electron volts is in between energy level 2 and 3, but not exact. So nothing would happen. Okay. So in order for the electron to get excited to the next or the further energy level, the energy of the photon striking it has to be exactly the same as the energy gaps between its energy level. Okay. So look at the next question. What would happen if the hydrogen gas was irradiated with photons of exactly 10.2 electron volts? Okay. It will jump to the next energy level and soon come back. Okay. So electron jump to the 10.2 electron volt energy level and returns to ground state, releasing energy or emitting light energy, right? Releasing light energy of 10.2 electron volts. Okay, so it will jump up and come back down. During the process, it releases this type energy. Okay, so an electron in hydrogen excited to so n equal to 3. So somehow we have 12.1 electron volts photons strikes on the electrons. So the electron will jump up to here, then come back down. Okay, and in this case, what happens is the electrons has options. It can come back down straight from the third energy level to the ground state, or it can come back from this energy level to the second state, okay, then come back to the first one. Okay, so when it's doing this, when it comes back directly to the ground state, it releases photon with energy of 12.1 electron volts. However, if it does this during this process, it will emit energy of photons of 12.1 take away 10.2. Okay. The difference between the gaps, 12.1 take away 10.2, which is 1.9 electron volts, and then releases the rest. Okay, so in this scenario, what's going to happen is we're going to say that the material emitting 3 different colors of light. One different colors of light is this, one is this, one is this one. Okay, so when, yep, okay, so if you can have a look, um, let me show you this. Just remember, we have the absorption spectrum, we also have an emission spectrum. Okay? The emission spectrum shows the color of light that the material can emit. Okay? And if you have a look, this is for hydrogen, that's for sodium. Okay? So it emits this kind of colors there. And compare with the absorption, what we looked at, it will emit more color of energy because when electron returns to its ground state, electron has options. It can break into, it can go down from level 3 to level 2, then to level 1, or straight from level 3 to level 1. It has more options. Okay? So in order to do question D, question D1 asks what are the energies that can be what are the energies that the emitted photons can have. Okay? The emitted photons can have energy of 12.1 electron volts, energy of 1.9 electron volts, or the energy of 10.2 electron volts. Okay? And from those values, we can calculate the wavelength and the frequency of the light it emits. Okay. So remember the equation. So in this case, we're looking for the wavelength. So energy is C H divided by frequency. Okay. So for each of this, if we sorry, wrong equation divided by the wavelength. Okay. So for each of these three energy levels, okay, we can rearrange the equation. Okay. Just substitute the number in. You'll be able to find three different wavelengths, which are the wavelengths of the light that it would emit in this case.